I heard a comment earlier today saying that the PUE problem was largely solved. I think there's a lot of great ideas out there, but we are one heck of a long way from almost solved. And so the driving force behind the panel today is to talk a little bit about some of what's been learned by the folks on the panel. My biases, you'll probably pick up on, are one for a higher temperature. I think higher temperature drives a lot of costs out overall, so I'm a big fan of that. Second one is aggressive airside economization. I'm also a big believer in, even in some of the hottest climates. So that's biases that I bring to the table and some of where my interests are. Plan of attack for this thing. Well, first of all, let's correct eBay. I'm Amazon Web Services. Much as I love eBay, probably not going to be popular having listed as eBay.
You can auction you off.
We'll auction me off. There you go. Okay, so plan of attack for today is each one of the panelists will speak for 5 minutes. I'll keep an eye on the time and cover two things. One is briefly introduce themselves, and the second one is talk about something innovative they've been involved with that they think would be a good contribution to you all today. So let's start off.
Okay. Hi, I'm Chris Malone. I lead Google's data center research and development team. And James asked for 2 slides for this session, and the first one is on some efficient design choices that we've made. So what I'm showing here in this slide is not an engineering drawing, but it's a kind of a cartoon representation of one of our favorite cooling plant designs. And to echo James's point, we're a big fan of utilizing economizers and minimizing the use of mechanical cooling whenever possible. So this particular design achieves that by putting a heat exchanger in line with your chiller. So a very simple concept. The hot water returning from your data center floor meets the cooling tower, and if it's sufficiently cool, then you don't actually need the chiller, or you can minimize the amount of chiller tonnage that's required. So you enhance that effectiveness or reduce the amount of chiller time by increasing temperature. Again, another thing that James pointed out that we're definitely in agreement with. A design like this that enables economization can be used with an evaporative cooling tower or with an air-cooled tower as well. Right? So this is an option that's flexible depending on what resource you have at your given site. And as Dean said, you can't always pick your location around power and cooling optimization. As much as we'd like to make power and cooling the most important thing, serving customers and latency requirements tend to come first. So this example is something that we've used multiple times in multiple geos, and it's proved to be pretty effective. Next slide, please. Unusual design choice. I called out the entree battery. This is something we talked about back in 2009, and we've been using for many years in our facilities. When it was designed and developed back in 2005 or so, it wasn't something you could actually buy in the market, and UPS technology has come a long way in that 5 or 6 years or so. But what this offered was a scalable UPS design. We essentially ship a small battery with each of our servers or our storage trays, and it allows you to scale your UPS. So the traditional model of building a massive UPS room and you slowly fit out your server room yields, you spend the CapEx up front and your efficiency isn't so great for a really long time. This allowed us to trickle charge the UPS, so the effective efficiency is ridiculous. It's approaching 100%. And when it's needed for transition to generator or so on, you take a small hit. But overall, incredibly effective. And what's been encouraging to us over the last few years is we've seen designs like this emerge from other vendors. And just generally, the efficiency of the UPS offerings commercially available has gone up. So the comment at the end there is this particular design requires custom machines. It's not off the shelf, but what's great is actually we see a tremendous improvement in what's generally available. So it was it was a requirement for us to go do this years ago, but now it seems like it's something you can just buy, which is great. Okay.
Good stuff. Thank you.
I'm Rob Coupland. I'm Chief Operating Officer for Telecity Group. For those of you that don't know us, we're a co-location provider, and we operate around Western Europe. We're currently operating 24 sites around major internet hub cities, somewhere around 60,000 square meters of raised floor, and about 60 megawatts of customer IT capacity deployed at the moment. We've also got a fairly extensive rollout program that goes out over the next 2, 3, 4 years, which will take that capacity up to about 110 megawatts. So what I thought I would do is just share a little bit with you what we've been doing around best practice. I'll start off with some of the drivers behind that, and then just think about that in terms of the way we're thinking about the design paradigm now, but also, and probably where I'll focus more of the time, what we've been doing to try and go back and optimize some of those sites that we've got that are 10, 11, 12 years old now. Next slide. So drivers, again, I think we've talked about this a little bit this morning, but for us, as a public company, lots of pressure both from regulators. I think that's particularly a dynamic we're seeing coming through now in Europe. Some of the things we've seen in the UK certainly bring that sort of right top of the list. Investors, CSR is important, and we do see our investors challenging us around what we're doing on this. So, making sure that we keep the investors happy and investing is important. Customers, one of the big changes we've seen over the last 2 or 3 years is the way our customers are engaging with us. Very different dynamic on how people are thinking about this. But you know what? The real kind of crux of this is that energy is expensive. It isn't going to get cheaper. So actually, the key stakeholder here is our finance director. So for us, the business case is really, really clear, and this is, it's a no-brainer, as they say. Okay, so next slide. So just want to contrast here the difference in paradigm that we see between the sites we built in sort of 99, 2000, and then what we're doing now. And the point here is that back in the day, the focus was on space. The focus was on making sure that these things were ultra resilient. There wasn't an awful lot, cooling was a secondary consideration within there. And, a real kind of dynamic that we saw there was the, shouldn't it feel cold in here mentality. So if there was a discussion around customer engagement at all, it was actually around, how we get some fairly low temperatures in SLAs. But it was a fairly limited engagement. And I think, overall the whole kind of environmental issue wasn't on the agenda in the way it is now. So where we see ourselves at the moment is, power absolutely is the critical resource here. It's no longer about space, it's about power, and it's about how we deliver that. But also in the wider context, power becomes an even more constrained resource. I think we see that. I think we see constraints coming through in supply, and that will only lead to an upward pressure on prices. But also I think the key difference is that cooling and efficiency are the starting point on design now. So the need for resilience hasn't gone away, but our starting point is thinking around how we're going to make this efficient and how we're going to cool it. The client engagement is remarkably different. People are talking to us sensibly about set points and temperatures, and that's leading out to a lot of different options around how we really harness the free cooling periods. And then, total cost of ownership, rather than just selecting plant on what's the cheapest. Okay, so moving on to the next one. This really is where we've been innovative, is really embedding within our business a model for driving efficiency in the site. So this is getting a framework right through the group that embeds in the way we operate a cycle of driving best practice. It's driving a centralized approach to auditing that, using things like the code of conduct as a framework of best practices, and then simply going through the sites one by one, making sure we have a plan of action for each of the sites, looking what we can do and driving that. What we've also done is used 14001 as a management standard to embed that within the business to really kind of challenge through. And then, going through the basics that we've heard a lot of this morning, airflow management, cooling system management, plant refresh where it makes sense. Allocate the spend into the places where you get the best return, and this becomes a self-funding program. Okay, thank you.
Next slide, please. And the next. come out of sync. Ian Bitterlin, CTO of Ark. We design and build and operate data centres for other people. So we have 80 acres of land on 2 sites in the UK, 150 MVA of power laid in and connectivity. We have 3 basic products, bespoke, that's whatever the client wants he can have. And we have 2 standard products which are quite interesting to compare today. One is a conventional chilled water, raised floor, free cooling, electric chillers, with relatively low water usage, because in the UK we don't use cooling towers, which we can talk about later. And the other one is a fresh air solution, so filtered fresh air, humidified, brought into the centre. And I'd like to highlight the difference in water consumption between the two. So next slide, please. So it's very rare to see water-cooled towers in the UK, mainly because of Legionnaire's disease. The local health man will come and shut down your data centre. Happened in Edinburgh a few years ago. We had several deaths from a Legionnaire's outbreak, and it shut down the financial district in Edinburgh, in any centre that was using water towers. So very rare to see it. Air-cooled electric chillers are the norm. Fresh air solutions with adiabatic cooling are definitely on the increase in terms of customer interest. But at first sight, those fresh air solutions consume 100 times as much water as our conventional chilled water solution, because we don't use cooling towers. Next slide, please. So you realise that this is a very UK-based presentation, but you can do this same calculation wherever you are in the world, and it more or less covers all of Northern Europe. You can see how much water you need to humidify fresh air. Depends on your local climate. I mean, if you've got a very dry climate, it takes a lot of water. If you've got a very humid climate, it doesn't. And it does depend on the limits. So on here, I've put everything from a conventional 18 degree, 24 degree, 45 to 65 RH system. That's the system we're building currently, which needs nearly 1 million litres per megawatt per year. And right the way down to the ASHRAE allowable at the bottom. So 10% of that, if you allow your humidity to extend below down to 20 and up to 80. Next slide. You can read these later, you certainly can't see them now. Where you are in the world depends on what water consumption you've got in your grid. So in the UK, if you do these numbers, you come out to the figure of 1,500 litres per megawatt hour is actually consumed in the grid manufacturing your electricity. That's interesting because the PUE that is enabled by a fresh air solution actually reduces your power consumption, so is reducing your water consumption in the grid, even though you're using more water locally. And next slide, please. If you do the numbers, maybe you can see that. Oh yes, you probably can. I can't. You're not even with my Specsavers glasses. You can go from a PUE of 1.1, then it goes all the way up to 2.5. I've given you a couple of architectures and legacy and industry average. You can see what happens to the water consumption. The water consumption just keeps going up in the grid as your PUE gets worse. So next slide. If you combine the grid and the local, you can see what happens. The architecture number 1 is the fresh air solution, varying expansion of the humidity, so from up to the ASHRAE allowable now. And then architecture number 2 is the best practice raised floor, then industry average and legacy average. And you can see that in fact going for a fresh air solution with high water consumption locally does use less water. But, and this is the but, obviously it uses less water as long as you don't use potable water and as long as you've got water free for use in the area where you are. And that's one of our problems. We're having to build rainwater storage, because even in the UK, I think rainwater is actually falling. And water is a precious commodity. And in some places in the world, you don't have access to water. The only other point I can make, which is not on the slide, because this is the last slide, is the fresh air solutions also consume a lot of land. So a lot of space, a lot of real estate. So it won't be suitable for everyone that's in a city centre, for instance, either. So water consumption can be proved to be less, but certainly goes up locally dramatically. Thank you.
Thank you. Brian Waddell from Norman Disney & Young. We're an international consultancy of M&E engineers. And my credentials for being here, if you like, are that we've won several awards for energy efficient data center design. And the task of designers is to produce a solution that meets our clients' needs. But that is normally constrained by a number of factors. Those factors could be budget, they could be geography, they could be space, etc., but also making use of any opportunities we have. And this slide depicts some of those opportunities. This slide demonstrates the temperatures in and around London across the year. So how many hours at a particular temperature, and from that you can see that there's an opportunity there to use free air cooling. And the 3 bars across the top demonstrate 3 different ways that can be done. One way is with typically free cooling chillers at the top, where you can get a fairly short period of total free cooling, a reasonably long period of partial free cooling, and then mechanical cooling on top of that. The next solution down being something where we would use direct fresh air, and that direct fresh air, building on what's just been said, is one of the data centers we won a big award for in the north of England, where it's nice and cool. And for the vast majority of the year, the data center is cooled by fresh air and nothing else, saving vast amounts of energy. And the last, for completeness, the last line is demonstrating an adiabatic cooling solution, much like Blade Room and other people, Xcool and like, who are rolling out that type of solution. So our task, as I said, is to make use of any opportunities we have, and certainly fresh air cooling for the lower density end of things is something to be looked at if you have the space. Thank you.
Great. Thanks everyone for the introductions and going through some of what's been worked on so far. One of the questions I had for the panel is, we're seeing a lot more use of free air cooling. It looks like for where you have the space and the capability and access to outdoor, it looks like a pretty clear win. A lot of concerns about particulate ingestion, humidity control, forest fires nearby, diesel engines running, that kind of thing. Tell me a little bit about how much of a concern you think this actually is, how concerning particulate ingestion is. Do you have to be able to close the systems down, or do you believe in filtration? Why don't we start with you, Chris?
Sure. I think the answer is it depends on where you are and what your business needs are, right? So we've certainly using outside air is attractive from a capital perspective and so on. But you may need to size your mechanical cooling solution to support a closed system. So that can be quite impactful depending on where you are. If environmental conditions are actually a concern, and you can have forest fires or sulfur in the air can actually impact your IT load. So it's not entirely clear, and I think what's also interesting is there are many ways to be efficient, right? So outside air is sort of one of the latest things we were all talking about, but there's combining a cooling plant cycle like I showed earlier with best practices can get you pretty far in terms of PUE. So I guess we shouldn't obsess on any one particular solution. There's many ways to get there.
Yeah, it looked like you had a comment.
Yeah, it's quite interesting. You can use outside air with an air-to-air heat exchanger and get over that problem, but you are obviously you're extending those, say, 100 hours a year where you might need mechanical cooling to 200 or 300 because you can't get the approach temperatures. But the most interesting thing is, if people think, well, customers generally think that if they're having a fresh air solution, they're going to save on CapEx. And I'd say they're not. They're probably going to actually spend more on CapEx because you're going to have that mechanical solution in reserve. And that has two impacts. For instance, the solution we're bringing out does have 100% capacity to be able to shut off the outside air and recirc the inside air, 100% on DX. Now, it doesn't affect the PUE for doing it for 100 hours a year if you work it out. What it does affect is the use of your grid capacity, your utility capacity. And what you end up thinking about is having generators that are oversized compared to your mains incoming grid, because you don't want to have your grid capacity there ready for a PUE of 1.8 for those 100 hours a year where you need mechanical cooling. That's a waste. It's a waste of money, it's a waste of energy, and it's marginally a waste of efficiency as well. So you end up with oversized generators, and then you try and tell me how that fits in with your tier classification. That's a really interesting concept to discuss with somebody. But generally, I think air-to-air is possible. I don't think there are many places in the world where you can't afford, with a critical environment, to say you can't shut off the outside air. You must always be able to shut off the outside air, even if it's pollen. a chip fire, down the road. You can never get the smell of hamburgers out of a data center if the oil catches fire.
I kind of like that.
Yeah, well, it makes you hungry, but at least you'll be hot inside, so you're more likely to want ice cream, right?
I've seen a couple approaches used, one consistent with what you described, where if you're in an environment like Dublin, where you really can run, for the most part, without DX cooling, putting an inefficient DX system, a low-cost, inefficient DX system in, and using it sparsely is one approach I think actually makes a lot of sense. Another approach, is a little bit more aggressive, is the Facebook Prineville, Oregon facility. There's a wall the entire width of the data center, about 12 to 14 feet high, that's 100% filtration. And they chose not to go with the DX facility at all. They are 100% outside air. They have no other means of cooling that facility. But what they've done is they've innovated on the filtration side, and I think that's an interesting approach as well.
I think just to build on Ian's comments, the HP Wynyard data center up in the northeast of England has to give you an idea of the scale of it, a filter bank that's 7 meters high, runs the whole length of each of the 1,000-meter squared halls. It has a close-down mode, and chillers sitting by, should they be needed, in case there's a truck fire, forest fire, people burning stubble or whatever else. And in terms of the cost, it was about 11% more expensive than what we perceive to be the standard data center solution.
Good stuff. Urge the audience to get some questions together. I'll ask one more. What about humidity range? I've heard discussions that range from anything short of non-condensing is fine, and non-condensing is easy in a data center because whatever the outside air coming in, it's certainly going to be warmer as soon as it enters the center. So non-condensing is pretty easy. I've seen that on one end of the spectrum, all the way around to much more than 40 or 50% relative humidity is very dangerous. Any guidance from your experience on humidity levels?
I've got one comment. It actually depends on the end user, I think, these days, because if we go to Dean and eBay and his refresh period was 2 years, I guess I nearly laughed as well. Sorry, but I have customers that wish they could do it every 20 years. But there we go. But I think if you refresh every 2 years, the humidity range, you can take ASHRAE to its full limit of 20 to 80% without any trouble at all, because the danger from high humidity, and I think the new ASHRAE white paper is very good. There's a 60% limit in there for continuous relative humidity higher than 60% shortens your hardware life, but in 2 years it doesn't. I don't think so, but maybe 4, maybe 5. So I think it's an interesting discussion to have. There's a whole green issue about sweating your assets, and if people insist on believing some things that, for instance, Greenpeace say you should leave your servers running there for 30 years to sweat their assets, regardless of efficiency or whatever, you're going to run into those sort of problems. But I don't know where that line is yet. But intuitively, if you think about it, a lot of the servers aren't designed to run in humidities of 60, 70%, even though the ASHRAE allowable is 80. It's meant to be 80 for short excursions, not continuous. But I think that's as an industry we've got to sort out, I guess, with ASHRAE, are those allowables for continuous use or just for excursions into? The ASHRAE document as it stands is quite clearly just excursions into, not continuously running at 27 degrees centigrade, 80% RH.
I think that's right. I think the other thing, as a service provider with numbers of different clients within the sites, you've got to provide set points that kind of deal with the mass of what everybody wants. And I think what you can do in a very specific own-use site where you're absolutely making your own judgments is very different to what's going to be an acceptable market standard for general use. So I think it will evolve for sure, but again, there's an awful lot of equipment out there that's in our sites that's much older than 3 or 4 years.
This is one of the areas where groupings like this that Google's organized is really going to be useful, because there's people in the industry that are exploring the bounds of what can be done from a relative humidity perspective and from temperature. As that data becomes more broadly understood, we'll get a view for how much can we push before we really have problems. Because a lot of what I've heard written is well thought, legitimate engineering concerns, but not with a lot of data. So getting data will be the key. Questions from the audience. Dilip, it looks like you've got something ready for us.
I'm wondering why we should sort these issues out with ASHRAE and not the IT equipment suppliers.
Is there any microphone in the mic? Let's take one of these microphones and pass it down. Dilip?
I was wondering why we need to sort these complex issues with ASHRAE and not the IT equipment suppliers.
Because I think ASHRAE are the IT equipment suppliers. No, they're not. TC 9.9 is contributed to by the IT equipment industry. They sign up for those. They sign up for those limits. They're a party to it. Without it's a symbiotic relationship. Without the IT industry's good grace, and if you can possibly think IBM's capable of good grace, but there we are. If you think that ASHRAE could publish something that IT equipment vendors wouldn't produce, that's wrong. They are absolutely symbiotic.
That's not true, because the IT equipment guys are more than happy to live within a restricted environment, and they support a wider one than ASHRAE recommends. That's completely not true. The equipment suppliers are more than happy to live within a more constrained environment, but they support a much wider one. So saying that they support ASHRAE is not true. They're willing to support a much wider range, and if you look at what ASHRAE stands for, the word IT is not in any of those initials.
We get a question at the back.
So the gentleman from eBay is very keen on liquid cooling. What do the panel think?
It's a great question.
I've got the baton, so I should speak, I suppose. From a designer's point of view, one of the challenges that we have is that most of the time we're designing data centers for that have a life of 10 or 15 years. It's very difficult for us to provide sometimes costly, to provide a solution that's going to last for those 15 years. We need to have a robust and flexible design in place to cater for the different types of technology that are on the horizon or are coming. I would love one of my customers to start talking about hot water and get in amongst that, but at the moment I have none.
It's one of the joys we're lucky with some of the, in the case of Google and the case of Amazon, because we have an internal population, we get to control the horizontal and vertical. Same thing's true in Dilip's case at Microsoft. When you get a little bit more control, it allows you to experiment more and push the limits a little bit more. I think a lot of colo providers, colo consumers would not be comfortable with higher temperature, high relative humidity.
Yeah, no, that's absolutely right. I mean, again, it's not something that we're asked for, but I think also, there are applications out there, and we heard about a specific one there with eBay that drive extremely high densities. That's not the reality of where most of the demand is. We're typically building sites at an average density around 2 kilowatts a square meter. And actually, you know what, the typical rack is still around 3 kilowatts is broadly what we're seeing. So the key for us has been building sites that have the flexibility to go up. So on that floor area, we can do a 20 kilowatt rack quite easily using chimneys and cold air segregation and so on. And actually that covers the range. And I think, what absolutely comes through still is that people don't want water on the data floor.
Ian, did you have a comment?
Specifically about the question, there's a supercomputer here in Switzerland that's already running a baby oil immersed system. Somebody laughed. It's actually true. It's the same dielectric fluid they use in transformers. It's ingestible. You take the standard servers, you take the hard drives off and seal them. You change the CPU grease, and you drop the servers straight in a bath of oil. The reason they're suitable for supercomputers is you can turn the clock frequency way up, way up to get your point. You get the density of 100 kilowatts equivalent in a 42U bath. You got to turn it the other way around, not think of vertical, but think of horizontal. But the point is, and you get a PUE of 1.05, no question. Because the oil can run at very high temperature. It's always colder outside. You don't need any mechanical cooling. The point is this. Most of the industry is in the colo and non-risk business and lowest common denominator business, so that technology is perfect for supercomputers and maybe even eBay. Someone that wants to do one job a lot very quickly and will invest in that technology. Unfortunately, we're in a very risk-averse industry, and generally, regardless of the fact that it's a 1.05 PUE, people say, well, there is a limit to what risk I'll take.
Let's let Chris fill in on this, and then I'll transfer over to Dean.
Yeah, so one of the interesting things about liquid cooling is every server OEM has a liquid cooling solution. You know, I designed servers for 10 years before I came to Google, and I had several, right? It's not a technical challenge. IBM solved liquid cooling in the 70s. It's a business problem. So if you can extract a couple extra speed bins from your processor, yeah, maybe it's something that makes sense. It really comes down to server technology. The data center infrastructure is actually relatively cheap, right? If you amortize over long periods of time, even expensive power and cooling solutions look relatively cheap compared to your servers. So it's really kind of a chip bottleneck, if you will. If we can unlock more performance by running chips cooler or you know, extracting more power and getting more performance out of it, then yeah, it makes a lot of sense. But generally, that hasn't been an option, right, in the market, right? Air cooling has been very sufficient for extracting great performance per watt to date.
Dean, you had a
So,
comment.
yeah, so and I agree. I think that, you know, when you start to get to the higher densities, that's when liquid makes sense, right? Air makes perfect sense for the majority of the world. I think the thing that's going to change is look at cloud. The whole idea is that the 70 or 80% of server rooms and everything else that people have, just working, those things can potentially go to the cloud. And as the cloud starts to consume more of everybody else's workload, wouldn't you want the performance of those things to be able to have a gas pedal? So I could see large colos getting into cloud providing things, infrastructure as a service, platform as a service, having the capability of that engine underneath as something that could consume it. But it is the people that are going to higher density that will get the biggest benefit.
Don't fully understand that, and it seems like 25 kilowatt racks is independent from gas pedal and being able to control load, things like that. It really feels like, I think the question on density is one of, is it cost effective to have extraordinary density or not? Everything else, I think I understand and I totally agree with. On the density question, I think there is room for discussion there, in that Google and Facebook showed us 30 server racks, incredibly low density, 1.5 RU. What Dean showed us was incredibly high density racks. And so a question I'd like to toss off to the members of the panel is, give us a rundown on your take on density and tell me how to think about it.
Yeah, I guess I would return to what I just said. If you can amortize data center costs over 20 years, they actually look pretty cheap compared to your server expense. So, you know, it's beneficial to have lots of flexibility in terms of how you deploy. And so, sure, densification is good in the sense it uses less footprint, but you really have to look at this in the overall context of what you're trying to achieve, right? So we found that data center costs are actually, it's not that hard to add extra space to deal with your compute load, and you can spread it out. But you know, your mileage may vary. It depends on where you are. If you're in Manhattan on an office floor, or somebody used that analogy earlier, then certainly density is important. But if you have more flexibility, then it's not as entirely clear to me.
Sorry, building on that conversation, about the only time we've ended up using very high density solutions have been with a CO2 cooling system in a bank in the City of London. Again, their retail costs and space was so high that it pushed us in that direction and pushed them in that direction, and the right solution for them was that high density cooling. Almost everywhere else, space isn't that expensive, and we've ended up spreading out the solution and obviously dropping the density of the space, where air makes much more sense. Yeah?
And I think if you take the eBay approach, but with a different business model, your business model is fairly unique. You have to accept that. But if you take that same holistic total cost of ownership issue, what you find is that as the power costs have been going up, and they've been going up 20% per year and will do for the next 10 years, the power piece becomes dominant in the TCO. And actually the property piece becomes the minor point. So IT hardware costs will be outdone by power costs, and it'll be the lowest thing on the list will be your real estate cost. And under those circumstances, you're actually better off building bigger real estate and spreading the load out and going for higher reliability. eBay doesn't agree, but I don't care. I pay your fees. That's fine with me.
I completely agree. I think it's one of those classic cases that in engineering the answer is always it depends. I think broadly speaking, density is less expensive than power. We have to be very focused on power. There's always exceptions, though. Downtown New York's very expensive. Tokyo's very expensive. There are places that need unique designs. And so I think the right answer here is going to be us having a portfolio of solutions and being very versatile in how we apply them. Do we have another question down here?
Yeah, it's a great discussion. There's so many questions that I have, but I'm going to focus. Rob, you mentioned that you have customers that come in and say, shouldn't it be cold in here? And that's one of the worst things that we can do as an industry, but yet one of the things that drives the co-location facilities most is that feeling of must be cold to be reliable or to be operating right.
And I think what I was contrasting there, that if I kind of wind back even 3 years ago, that was still, very much how people were thinking. We've seen a shift in that over the last 2 or 3 years. One of the interesting things we did as we started to roll out the best practices from the Code of Conduct is we went and bought something like a $250,000 of blanking panels, which we went and distributed amongst our sites and put them down in the on the data floors and said to our customers, help yourselves and fill in the gaps, which caused a bit of a ripple because they weren't entirely used to the idea of a colo giving something away. But what that did is it opened out a conversation about why we were doing that and what that was doing around performance, which actually, first of all, helped us deal with some of the wrong orientations we had in some of those really old sites. So people started to engage in that. But it just started to shift the conversation a little bit with customers. And again, what we've seen is customers have the same kind of challenges as us. And I think some quite sophisticated customers that understand that in outsourcing into a co-location environment, they're not getting rid of their responsibilities. And however much people talk about colo providers potentially becoming a carbon sink, that doesn't really work because there's a huge amount of PR and bad press that can go with that. So you get quite an engaged conversation. So I think, in the older sites, we have the challenge of the legacy, which is we have, in some sites, hundreds of customers that have SLAs that ties into some things that mean we can only move that fairly slowly. Yeah. We are doing that, and as people come up towards renewals, then we'll move those, and then we can gradually move set points along. But we have a very different approach and different SLAs when we deploy the new sites, and generally that's playing out okay.
And customers are okay with that. When they come in and you say this is the way it's going to be, we're going to run it.
Yeah, absolutely. 27. And again, remembering that in a new site, and again, we're not pushing to the extremes of where ASHRAE say we can go to. We're still within the realms of somewhere that people feel comfortable with. And when people come into a new site, they're generally bringing new equipment in there, and so it's fine. When you look into an older site, you've got partly the challenge of the SLA and partly the challenge of some fairly old equipment in there. And again, people running things on equipment that they can't quite remember how it's running and what's going on in there, but it's definitely working, yeah? So you've got all of those kind of issues to deal with.
And then just quickly, you mentioned the idea of letting the program become self-funding. So presumably you had some sort of ante to get into the program. Give us an idea of the numbers if you
Yeah,
have.
sure. So we did some work and looked, at the time we started this, our power bill was somewhere around 25 million pounds a year across Europe. And I fairly boldly kind of went in to see the finance director and said, if you give me £1 million, I'll take £1 million off the energy bill. So he said, okay. So what we did was we picked out our 7 most power intensive sites, which was about half of our load, and we did some work to deep dive on all of the things we could do within there. And we just, we put them down on the list. And there was some really basic stuff which, kind of goes in the category of good operational practice. Get rid of the gaps in the floor tiles, get the vents in the right place, get, all of that kind of stuff that you just should be doing. But then, we looked where the investment should go. So blanking panels was one thing. And the point about the blanking panels is it doesn't necessarily do anything in its own right, but what it does is it starts to deal with some of the hotspots. And what we were typically finding within the sites is you have hotspots, and the old-fashioned way of dealing with that is you just kind of turn up the cooling to deal with that rather than getting to the root cause of the problem. So you start to deal with the hotspots, which means then you can start to optimize the cooling down. But then simple things like retrofitting variable speed drives onto crack units, the payback on those is a few months per drive. So, we just kind of picked out the best return, prioritized them, and then just did it. And we got a payback on that £1 million investment in less than 12 months.
That's the best way to contribute, by the way, is ASHRAE can set standards, and what we've learned is almost every data center runs well within the ASHRAE standards. What really works is us getting data out there and people getting used to and getting comfortable. Yeah. Because the truth is, we can set standards, and unless people are comfortable and actually have the data to support the comfort, they're not going to use it. I think we have a question up here.
Is this on? Yeah. Can you hear me? Yeah, hi, this is Gary Cook with Greenpeace International. Building on James's point about the need for more data, how do we get beyond some of the barriers to reporting more data, and especially data that reports to sort of the resource consumption that has not been common in the sector, due largely to competitive concerns? And how do we get past those concerns and use a specific example? How many of the companies on the stage are planning to report under the new CUE standard?
Happy to take that sort of head on. I think one of the challenges is that, and I think PUE is a great example of this, the kind of the PUE arms race becomes quite meaningless. Because people talk a lot about end states, and actually the real challenge here is that a lot of these sites don't reach the end state for quite a while. It takes a period to fill them up. And even when you've got them full, the load's going to grow over quite a period after that. So, one of the things we're looking at is how do you optimize this through the life cycle of the site and not just some hypothetical endpoint. The second thing then is that you can't compare PUEs very directly between sites because, the age, the geography, all kind of things play into that. So I think we actually are quite excited by CUE. I think we see that as a meaningful measure. It's one that we're doing some work on inside at the moment to understand how that works and see what that looks like. But I think that for us is an interesting development and one that I think we can see some legs in.
Okay.
Good stuff. Well, thank you very much for your excellent questions. I'm sorry that we're running out of time. Let's pass our thanks on to the panelists for contributing. Thank you very much.